This video is brought to you by Squarespace, the tool to use to make a website for your brand and grow your business. More about them in a bit. If you have to associate Russia with extreme climate conditions, you're very likely conjuring images of whirling snowstorms, rivers frozen solid, and vast expanses of woodlands enshrined in crystal clear ice. To put it simply, Russian weather is kind of cold. But from the end of June to mid-August 2010, Russians west of the Ural mountain range experienced the highest temperatures ever recorded in their country, gasping for air under a draconian sun, partially obscured by the acrid smoke of burning forests. Plants wilted, crops failed, the soil cracked dry. Thousands of citizens sought relief from the heat by diving into lakes or rivers. Hundreds of them would not return to shore, swallowed by the waters. And many, many more would die as a consequence of the extreme heat. This is the story of the 2010 Russian heatwave. So let's start off with some definitions. First of all, what exactly is a heatwave? The World Meteorological Organization defines such an event as a period of more than 5 consecutive days where the daily maximum temperature exceeds the average maximum temperature by 5 degrees Celsius or more. 5 degrees Celsius corresponds to 41 degrees Fahrenheit. From now on, I will use the Celsius scale as it is the one used in the affected regions. An easy conversion formula is to take the Celsius reading, multiply it by 1.8, and then add 32. Easy. Next, why do we define this event as the Russian heatwave? Well, the anomalous increase over average seasonal temperatures affected an area spanning across Western Russia, Belarus, Ukraine, the Baltic states, most of Western Europe, China, and North America. But the epicenter of the heatwave was, in fact, Western Russia. Here is where the effects of the heat were most devastating and better documented. But if we were to choose a location from which to begin our story, it would have to be the United States. 2 governmental agencies, NASA and the NOAA, the National Oceanic and Atmospheric Administration, picked up an alarming trend over the first 6 months of 2010. According to their measurements, during this period, global average temperatures were the warmest since records began in 1880. To give you some context, average global temperatures recorded in June 2010 was 0.75 Celsius higher than the 20th century average. The only time the average increase even got close to that was in June 1998, when the variation versus average was 0.73. There were a few notable exceptions. Russia, for example, was noticeably cooler than its surrounding regions. By early June, however, the temperatures were rising also from St. Petersburg to the Ural Mountains. This rise did not create any alarm initially, but it became apparent it was just a hint of the inferno that was to come. Day after day, mercury continued to rise. By the 20th of June, readings across Western Russia confirmed that a heatwave had indeed settled over the region. Temperatures stabilized during the end of the month and the first 2 weeks of July, but by the 18th of July, heat intensified again. Temperatures exceeded almost 8 to 10 degrees over the seasonal mean of about 30 Celsius, peaking at 40 degrees. Moscow's July 2010 temperatures were confirmed as the warmest ever recorded in the past 130 years. In all fairness, Muscovites and Western Russians were used to exceedingly warm Julys. For example, the summers of the years 1931, 55, 81, 88, and 2002 had experienced surface temperatures of up to 3 degrees higher than the seasonal mean. But these years, with a hot summer, had always alternated with much cooler periods. And in any case, a rise by 10 degrees was unprecedented. Towards the end of July, the heatwave expanded to Siberia, Ukraine, and the rest of Europe. But Western Russia still bore the brunt of the event. The extreme hot and dry weather sparked wild forest fire, setting ablaze some 500,000 hectares. Fires extended to the peat area south of Moscow. The blazing flames spread uncontrollably, forcing thousands to leave their homes. Clouds of black smoke clogged the skies and air traffic ground to a halt during most of July. Due to the absence of winds, the smoke from forest fire stagnated in the lower layers of the atmosphere, where it combined with increasing concentrations of industrial and vehicle pollution. Air quality quickly degraded, with high concentrations of carbon monoxide, ozone, and PM10 detected at surface level. Just to clarify there, the term PM10 indicates solid particulate matter with a diameter of 10 microns or less. Due to their tiny size, these particles can be inhaled into the lungs, inducing adverse health effects. For reference, a safe concentration of PM10 is considered to be 54 micrograms per cubic meter. Concentrations recorded in Moscow over that July exceeded 300, almost 6 times the safe threshold. Mercifully, on August the 18th, the cold front moved over Western Russia, bringing with it the gift of rain. The heatwave was over, but the infernal weeks had exacted a deadly toll. Now, just before we continue with today's video, I have to tell you about a service that you've probably never heard about before, Squarespace. Look, obviously that's a joke. Everybody knows about Squarespace, and that's because they're the absolute best place to build a website in 2022, and also because they've got lots of ads telling you all about Squarespace. But look, seriously, if you do need a website, there is no point considering anyone else. If the thought, I need a website for my business, blog, annoying political opinions, or whatever enters your mind, head to Squarespace. Why? Because websites are ridiculously easy to make and feature rich with them. Imagine the situation. You know nothing about websites. You love looking at them. You know there are ones that look pretty and work well and have all of these neat features. And now imagine that you need one of these websites. Maybe your old website that your mate made for you in 2013 is just looking a bit out of date and you need a refresh. Or maybe you've got a brand new business. Whatever. It doesn't matter. You should build this website with Squarespace. And yes, it works even if you want to sell stuff. Squarespace doesn't just do amazing blogs. You can also sell things, which is good if you have a business, or maybe you just want to sell memberships to your online cat yoga class. All possible. Not all sensible though, just possible. Plus email campaigns, analytics, social integrations, all of that good stuff. Plus super easy for even a beginner to put together. Perfect. Head to squarespace.com for a free trial, and when you're ready to launch, go to squarespace.com/geographics to save 10% of your first purchase of a website or a domain. And now back to today's video. At the start of the heatwave in late June, Russian officials took note of the increasing cases of heat stroke and sunburn amongst children, whilst adults already suffering from diabetes and heart conditions experienced a surge in complications. The first reaction from health authorities was to urge citizens to rest indoors in the afternoon to avoid exposure during the hottest hours of the day. The unforgiving sun caused asphalt to soften on the busiest roads, causing a slew of traffic accidents. In Moscow, city authorities dispatched trucks to spray down the streets with precious surplus water in an effort to keep the roads from melting. But it soon became apparent that these measures were not enough. As the heatwave dragged on, a state of emergency was declared across much of the country. During July and August 2010, Russian health services recorded an increase in excess mortality compared to the previous year's averages. These deaths were largely due to the high levels of atmospheric pollution and the accumulation of thermal stress caused by weeks of continuous heat exposure. Thermal stress is the situation by which the human body absorbs more heat than it can dissipate. This leads to adverse reactions such as rash, cramps, exhaustion, heat stroke, and the exacerbation of pre-existing conditions. Hospital admission records in Moscow showed a marked increase in mortality from coronary heart disease, cerebrovascular conditions, acute myocardial infarction, as well as from diseases affecting the respiratory, urinary, and central nervous systems. In general, the relative risk factor from all of these diseases increased 2- or 3-fold compared to the same period in the previous year. A study on ambulance interventions during July and August also gives a picture of the severity of this emergency. Ambulance calls related to stroke and angina increased by 2.5 times compared to 2009. The number of calls concerning acute pneumonia increased 5-fold. When the heat finally subsided, the Ministry of Health of the Russian Federation took some steps to develop a system to prevent complications of cardiovascular disease during future heat waves. By working with the Hydrometeorological Center of Russia, Lomonosov Moscow University, and other European meteorological organizations, they developed a system of weather modeling designed to help hospital and emergency services prepare in advance for extreme temperature waves. The negative effects on citizens' health described so far were mostly limited to Moscow, St. Petersburg, Archangel, and other large urban centers. Rural areas, on the other hand, were impacted by another type of calamity, a widespread and lasting drought, the most severe experienced by the country in the past 100 years. Crops due for harvest in the subsequent winter and spring withered and eventually perished under the heat. The desiccated plant remnants became prone to catching fire. According to the state-owned news agency RAA Novosti, approximately 9 million hectares worth of crops were lost during July and August. That's an area roughly corresponding to the entire surface of the state of Indiana or Wales and Scotland combined. According to Viktor Zubkov, the deputy prime minister responsible for agriculture, 50% of wheat crops were lost, whilst spring crops had dwindled to virtually nothing. The government stepped in with loans to save farmers from bankruptcy, but the overall economic problems caused by the heatwave were widespread and lasting. It was estimated that the drought cost the Russian economy some $15 billion, almost 1% of the country's entire gross domestic product. Moreover, Moscow had to impose imposed severe curbs on grain exports, which caused food shortages in wheat-importing countries in Western Europe and Africa. Now, crop failure and health complications are tragic yet predictable consequences of extreme heat, but the Russian heatwave was notable also for a string of deaths due to another cause, which hit the news in mid-July. On the 15th of the month, the BBC quoted an interview with Vadim Seryogin, department head at the Emergencies Ministry. According to Seryogin, on the 14th of July alone, 49 Russian citizens had drowned while seeking solace from their furnace-like environment. Seryogin revealed that a further 223 had drowned between July the 5th and July the 12th. It appeared as though some 1,200 citizens in total had died in Russia's rivers, lakes, and sea resorts between the end of June and mid-July. According to a 2015 paper by the British Medical Journal, Russia ranks among the top 5 countries with the highest number of accidental deaths by drowning, with 10,139 cases over the 2008 to 2010 period. The monthly average for the surveyed period is therefore approximately 282 drownings. During the heatwave, the number of drownings was almost 1,000 more than this average. So, what caused these numbers to soar? Well, naturally, the fierce summer prompted more people to take a dive, statistically increasing the chances for some of them to drown. But according to Seryogin, there was another explanation. Alcohol. In his own words, the majority of those drowned were drunk. The children died because adults simply did not look after them. In fact, Australian news outlet ABC News reported one incident where 6 schoolchildren drowned because the summer camp lifeguards on duty were too drunk to intervene. Taking into account those who died from drowning, victims of forest fires, and especially citizens who died from health-related complications, the death toll for the Russian heatwave was staggering. Between the 20th of June and the 18th of August, 55,000 excess deaths were recorded related to the heatwave. Roughly 1/5 of these victims died in Moscow alone. Thus far, we focused on the effects of the 2010 heatwave, but it is equally important to understand what may have caused it. And as you may guess, when trying to determine the causes of a complex climate event, scholarship is divided. According to a study by Randall Dole at the US National Oceanic and Atmospheric Administration, or NOAA, the heatwave was caused by a blocking high situation. This happens when an area of high atmospheric pressure intensifies to the point that low-pressure systems cannot break it down. So, let's just clarify that. A high-pressure system, also known as an anticyclone, is a formation of cool air which descends upon the Earth's surface. In doing so, it reduces the formation of clouds, prevents precipitations, and, in general, stabilizes weather conditions. A low-pressure system, or depression, is a mass of warm air ascending from the Earth's surface. As it rises into the atmosphere, the air cools down and water vapor condenses into clouds. This leads to higher chance of rain and generally cooler surface temperatures. The Eurasian region is particularly vulnerable to blocking highs due to its location downstream of the Atlantic westerly jet. Normally, blocking periods in this region last 10 days on average during July and August, but in 2010, the blocking high extended for about 30 days. Not only was the duration unusually long, but also the intensity of the high-pressure system was anomalous, 4 times stronger than any prior occurrence. This extremely long, extremely intense blocking high cleared the skies for weeks. Obviously, the affected area was exposed to the rays of the sun for a lengthy period, which gradually overheated the soil. Moreover, air at surface level was affected by so-called compressional heating. This happens when a lower layer of air is squeezed by a higher layer, applying pressure over it. The molecules of the lower air layer are pressed together, increasing the friction, which eventually increases the temperature. As a result of these events, temperatures soared above average, soil dried, and vegetation wilted. The subsequent persistent drought piled on the heating effect, pushing upwards thermometer readings. Randall Dole's study stated that the first 6 months of 2010 were the warmest since 1880 records, based on findings by both the NOAA and NASA. It also acknowledged that this general warming was consistent with conclusions by the IPCC, or Intergovernmental Panel on Climate Change, according to which most of the observed increase in global average temperatures since the mid-20th century is very likely due to the observed increase in anthropogenic greenhouse gas concentrations. However, according to the NOAA conclusions, quote, greenhouse gas forcing fails to explain the 2010 heatwave over Western Russia. In other words, the Russian heatwave was caused entirely by the natural process of atmospheric blocking. The NOAA study was partially contradicted by 2011 research led by Stefan Rahmstorf of the Potsdam Institute for Climate Impact Research. Rahmstorf and his team used a complex computational approach called Monte Carlo modeling. By using this method, they ran 100,000 simulations of climate patterns over Russia and the Eurasian region based on average temperature readings from the previous 100 years. The Potsdam researchers concluded that, with a probability of 80%, the July 2010 event would not have occurred without the man-made large-scale climate warming trends initiated in 1980, attributed to the release of greenhouse gases into the atmosphere. So, was it nature or was it man? These contradictory approaches were reconciled by a third study authored by Frederick Otto of the Environmental Change Institute at Oxford University and published in the journal Geophysical Research Letters in 2012. The Oxford scholars ran another series of models based on data collected from 1960 to the year 2000 to simulate weather patterns over the interested regions. In doing so, they computed two parallel sets of simulations. One set took into account the effects of man-made climate change, the other set ignored it altogether. Their conclusion was that greenhouse gases certainly contributed to increasing the risk factor of the 2010 Russian heatwave taking place. However, the Oxford researchers also concluded that the human contributions to the event may have accounted for a temperature increase of 1 degree above the seasonal means, whereas the July 2010 readings peaked at 10 degrees above average. In other words, human activity had indeed increased the likelihood of an anomalous heatwave taking place, but the apocalyptic magnitude of the increase in mean temperatures was mostly due to natural causes. So now the question comes, could a heatwave of the same magnitude as the 2010 one happen again? According to a March 2011 article published in Science by David Barria-Pedro from the University of Lisbon, the answer is probably yes, but not for a long time. Barria-Pedro and his team ran a series of statistical models determining that the probability of summertime mega heatwaves will increase within the next 40 years. However, the likelihood of an event the same magnitude as the 2010 Inferno in Europe will remain fairly low until the second half of the 21st century. The latest study on the same topic was authored by Simone Russo, working with the European Commission's Joint Research Centre and the Institute for Environmental Protection and Research in Rome, Italy. According to his findings published in the Journal of Geophysical Research in October of 2014, several regions in the US, Europe, and Africa will experience at least one extreme heatwave in the period from 2020 to 2052. This increase in frequency for anomalous climate events is linked with the rise in greenhouse gas emissions. As the increase in global mean temperatures approaches 4 degrees Celsius, the US and Europe could suffer very extreme heat waves every 1 or 2 years, and super extreme ones every 10 years, all before the year 2100. The World Health Organization has also analyzed the lethal risks posed by heatwaves in the future. According to its studies, in the years between 2071 and 2099, the European continent may experience up to 117,000 excess deaths every single year as a consequence of extreme heat. So, in conclusion, brighter minds than ours have determined that yes, before the close of the century, another lethal wave of heat and fire might scorch our dear Earth. While scholarship has taught us that nature is perfectly able to unleash climactic havoc by itself, it seems that we as humans can and should do something to decrease the frequency of these events and mitigate their most nefarious consequences.